All right, so we're going to be talking about conditional probability and the multiplication rule for this section. So suppose you're throwing two fair dice. So if I have two fair dice, that means my first die, I have 6 sides. And on my second die, I also have 6 sides. So if we multiply both of those, we're going to have 36, which represents 36 different outcomes. So let's say I want to find the probability of a sum of 3. So the first time I roll, I could roll a 1 and a 2. The second time I roll, I could get a 2 and a 1. Those are the only 2 ways that I'm going to be able to make 3. So that means there's 2 possible outcomes for that. So 2 out of the total 36, I plug that into my calculator, and I get 0.083 repeating. And so the probability of the sum of 3 is 0.083. So for most of these, what I want you guys to do is write it in the thousands. What if we throw the white die before the black die and we get a 1? Now what is the probability of getting a sum of 3 on the 2 die? Well, we have 6 possible options considering we're going to throw the white die first, or 6 outcomes. And so we want to look through these 6 outcomes and see which one is going to give us a sum of 3. Remember, we have to throw the white die first. So the second one, rolling a 1 and then a 2, is the only one that is going to give us a sum of 3. So the probability of a sum of 3, given we throw our white die first, is going to be 1 out of 6, because there's only one possible outcome that will work out of the total of 6. You plug that into your calculator and you get about 0.167. Remember, we're rounding that third decimal place. So if I'm telling you to roll the white die first, that's a conditional probability. So with conditional probability, it's the probability that a dependent event will occur given that another event has already occurred. So we notate it as probability of A given that B has occurred. So let's look at example 1. All 7,000 students at a college were surveyed about their residency status. They either live on campus, off campus, but in town, or they commute. The students were grouped by gender, and the results are showing in the following contingency table. So first, we're just going to find the probability that they are on campus with C. Okay, so the total students that are on campus are 3,500. And we want to put this over the total of students overall, or our population total, which is 7,000. So if we put 3,500 over 7,000 into our calculator, we're going to get about 0.5. So next we want to find the probability of M, which is the probability that they're male. So our total amount of males is 3,600, and that's out of the total population of males and females, which is 7,000. We throw that into our calculator and we get about 0.514. Next, what we want to do is we're going to find our conditional probabilities. All right, so for C, we're going to find the probability that they commute given that they are male. So first what we want to do is we want to find our total, which is our males. So again, remember, we have a total of 3,600 males. If we look at that row total, and then we want to find the ones that are on campus. So the on-campus males are 1,700. So we're going to have 1,700 over 3,600. Remember, 3,600 is the total. So we put 1,700 over 3,600, and we get about 4.72 as our answer. Remember, again, we're going to only round 3 decimal places. Now we're going to find the probability that they're male given that they are on campus. So we're going to look at the total that is on campus. Which is 3,500. And then the probability that they are male is 1,700. So it's going to be 1,700 over 3,500. That gets us about 0.486. Now we're going to look at the probability that they're off campus given that they're female. So we're going to look at the total of female students, which is 3,400. So for that second letter, you want to look at the total. And then we want to find the females that are off campus, which is 1,200. So we're going to have 1,200 over 3,400. When we plug that into our calculator, we get about 0.353. Next, we want to find the probability that they commute given that they're male. So since male is the second one, our total of males is 3,600. And then the males that commute is 600. So we're going to have 600 over 3,600. Plug that into our calculators, and we get 1.67. Lastly, we want to find females given that they commute. So let's look at that they're on campus. Let's look at the campus. So that's 3,500 total on campus. And then our female students that are on campus, which is 1,800. So we have 1,800 over 3,500, which then gets us about 0.514. So multiple events, both independent and dependent. So what if we are rolling die 3 times, or we're drawing 2 cards, one right after the other? So these 2 events are considered independent, all right? So if the occurrence or non-occurrence of one does not affect the probability that the other one will occur. So they're 2 different things. So our multiplication rule, you really want to look for that word and. So if we have the probability of A and B happening, that means we're going to multiply those 2 probabilities. All right. So for our second example, you roll a standard die and you flip a coin. So rolling a die and flipping a coin are 2 separate events, okay? So they are independent events. They don't depend on each other. They don't affect each other. And that's really how you can tell the difference. So if we're going to find the probability of an even number in heads, remember we're looking at a die and we're flipping a coin. So if we write out the numbers that go on a die, that's 1, 2, 3, 4, 5, 6, and we look at the even numbers, so that's going to be 2, 4, and 6. So that's 3 out of 6 are even. And then we multiply it by our options with flipping the coin, either heads or tails. So that's only 1 out of 2. So we multiply 3 out of 6 times 1 out of 2. And we get 3 out of 12. But as a decimal, we would write that as 0.25. Next, we're going to find the probability of rolling a 4 and then getting tails. So again, there are 6 sides on the die, 1, 2, 3, 4, 5, 6. And there's only 1 4. So that means it's going to be 1 out of 6. And then if we're flipping a coin, heads and tails, there's only 1 option of getting tails. So that's 1 out of 2. We multiply 1 out of 6 times 1 out of 2, and we get 1 out of 12, which is about 0.083. Next, we're going to select a card from a deck of cards, and we're going to replace the card. Now, that wording of replacing the card makes this event independent, all right? Replacing means independent. If we don't replace it, it's going to be dependent. So remember that in a deck of cards, there are 52 cards total. So the probability that we have a queen, there are 4 queens out of the 52. And the probability that we have an ace, there are 4 aces out of the 52. So our bottom number stays the same because we are putting the card back. You multiply these 2 together and we get 0.00 0.5917, but we want to just have up to 3, so we could say 0.006. Next, we're going to find the probability of 2 queens. So this is the exact same thing. So it's 4 out of 52 times 4 out of 52 because we are putting the queen back. So we have an equal likely chance we'll be able to pull it again. Multiply these two, and we're going to get the exact same answer that we did for A. So if 2 events are dependent, the probability of one event depends on the occurrence of the other event. In order to calculate the probability of a dependent event, you need to use conditional probability. So here is essentially our multiplication rule. We find the probability of our first event, and then we find the probability of our condition. Don't worry about these formulas too much. So let's look at example 4. So suppose you're going to throw 2 fair dice. What is the probability of getting a 3 on each die? So we want to decide first if this is an independent event or a dependent event. So this is independent because the rolling 1 die doesn't affect the other. So that's 1 out of 6 times 1 out of 6, and that gets us 0.027. Now, for example 5, we say, suppose you are drawing 2 cards without replacement from a well-shuffled deck of 52 cards. What is the probability of getting 2 hearts? So again, remember with a deck of cards, it's 52 cards. And so we're looking at getting 2 hearts. So if we're getting 2 hearts, our first is going to be 13 out of 52. And then our second one, since we are not replacing, all right, we're taking a card out, our total of cards is going to be 51, and our amount of aces is going to be 12. On this here, it should be 12 out of 51. I made a mistake on the video, but on the answer key, it is fixed. So when you multiply those two, you get 0.059 as your answer. All right, let's look at the next example. John and Lisa are going to take the driver's license test. Based on their skills, the probability that John will pass the test is 0.7, and the probability that Lisa will pass the test is 0.8. Assuming the test result of one of them has no effect on the other, so these are independent events, okay? They don't depend on each other. So for A, are the events that John will pass and Lisa will pass dependent or independent? You should circle independent. Now, what is the probability that they both will pass? So we're going to take both of their probabilities and multiply them together, and we're going to get 0.56. Let's look at example 7. You consistently hit 80% of your free throw shots when you practice. What is the probability of hitting the next 3 shots? So we know that we're hitting 80% every single time. So that's 80% these next 3 times. So we're going to go 0.8 times 0.8 times 0.8. And we're going to get 0.512. Next, let's look at example 8. In a jury selection pool, 65% of the people are female. Of these females, 1 out of 4 works in a health field. So A, find the probability that a randomly selected female is a female who works in the health field, okay? So our probability of female times our probability of female in the health field. So remember, our probability of female is 65%. And then our probability of female in the health field, all right, remember that's 1 out of 4, so we're going to multiply 0.65 times 1/4. We multiply these two together, and we have 0.1 0.162. Or we could do 0.163 because we're rounding. Find the probability that a randomly selected female does not work in the health field. So we're going to do the same idea. Probability that they're female times probability that they're not in the health field and female. So again, we're going to go 0.65, and this time we're going to multiply it by 3/4, because remember, 1 in 4 women are in the health field, so that means 3 in 4 women are not. We multiply them together and we get 0.488. Let's look at example 9. You pack a cooler for the beach and stock it with soda cans. You include a 12-pack of soda, a 12-pack of Diet Cola, and 6-pack of Red Bull energy drinks. You randomly grab 3 cans in a row and hand them to your friends. What is the probability that you, so notice since we're grabbing 3 cans randomly and we're not replacing them, it's a dependent event. So first let's find out our total of options, or our total of outcomes. This is going to be 30. We add all the soda totals together. So we're going to select 3 Red Bull energy drinks. So there are 6 total. So there's going to be 6 out of 30 that we can grab. If we grab 1, there's going to be 29 drinks left in there and 5 Red Bulls left in there. So we're going to multiply it by 5/29. If we happen to grab another one, that means there's going to be 4 Red Bulls left and 28 drinks left in the cooler. We multiply these all together and we get 0.005 as our answer. So what is the probability that we select a cola, a Diet Cola, and a Red Bull in that order? So first we have 12 out of 30. Now, if we're selecting a cola, then when selecting a Diet Cola, that's still going to be 12 because there's 12 total of those, but there's going to be 29 drinks left in there. So now we're going to have a Red Bull. So since we haven't selected a Red Bull yet, there are still 6 possible Red Bulls. However, there are 28 drinks available. We multiply those all together and we get 0.035. For example 10, your teacher is trying to demonstrate a probability concept and is running out of ideas. She creates 3 bags and fills them with 20 Scrabble tiles. So first thing that I'm going to do with these bags is I'm going to count the amount of vowels in each bag. Remember, vowels are A, E, I, O, U. So my first bag has 12, the A's and the E's. My second bag has 13 vowels, which include the E's and the I's. And my third bag has the I's and the O's, which are 6 vowels total. So it says for A, you draw 3 tiles out of the first bag, one after the other, without replacement. So if we're not replacing them, remember, these are dependent events. So we will be losing the total amount of vowels as we pull things out. So the probability of 3 vowels. So first we have 12 out of 20. Then we're going to have 11 out of 19, because remember we pulled one out. And then we're going to have 10 out of 18, because we pulled another one out. Multiply these all together and we have 0.192. Oh, I think it rounded up to 3. All right, so next is you're going to draw 1 tile out of each bag. So this is not going to affect the other bags, so this event is going to be independent. So 12 out of 20 for the first bag, 13 out of 20 for the second, and 6 out of 20 for the third. Multiply those all together, and we get 0.117. Lastly, it says you draw 2 tiles out of the second bag, one after the other without replacement. What is the probability of not drawing an E at all? So if we have 6 vowels, we're looking at the second bag. If we have 13 vowels, and that 9 of them are E's, and then 11 are not E's, we are looking for we're looking at the probability of not drawing an E at all. So that is going to be 11 out of 20 times 10 out of 19, because we're drawing twice. Multiply those together, and we get 0.28. All right, here is our last example. So if you're going to spin the colored spinner at the right, the spinner has 2 blue regions, 3 yellow, and 1 of each yellow, orange, and green. So what is the probability of the spinner landing on blue? So these are independent events. They don't necessarily affect the other ones. You always want to kind of consider spinner as independent because nothing can really be changed as you're spinning. Also, take in mind that there are 8 sections on this spinner total. So we're looking again at the probability of landing on blue. So there are only 2 blues out of the total 8. So that's 2 out of 8, which gets us 0.25. Now, what is the probability of the spinner landing on any color except blue? So let's look at the colors that aren't blue. We have a total of 6. So it's going to be 6 out of 8. And that simplifies to 0.75. Next, we're going to decide to spin the spinner 4 times. So these are 4 different events that are happening. So what is the probability of getting blue each time? So we know the probability of getting blue 1 time is 2 out of 8. So we're going to multiply it 4 times. When we do this, we get 0.004. Next, we're going to say to ourselves, what is the probability of not getting blue until the 4th spin? So we know the probability of not getting blue once is 6 out of 8. So we're going to multiply 6 out of 8 for the first 3. And then for the last one, we want to find the probability of getting blue. So that is going to be 2 out of 8. Multiply those together, and we get 0.105. Now we're going to look at least 1. So the complement of at least 1 is none. So these 2 probabilities should add up to 100%. So these are kind of like 2-step ones whenever you see at least 1. So the first thing that we're going to do is we're going to find the probability of none. So the probability of not getting a blue. And remember, we're doing this 4 times. So we're going to go 6 out of 8 times 6 out of 8 times 6 out of 8 times 6 out of 8. We're going to find the probability of spinning the spinner 4 times and not getting blue. And this gets us 0.316. So now using this, we're going to find the probability of getting at least 1 blue. So we're going to take the probability of none and we're going to subtract it from 1. When we do this, notice how where I got that from. And so when we go 1 minus 0.316, we're going to get 0.684. And that is the probability of at least 1 blue. Next, we're going to find the probability of at least 1 red. So we're going to do the same thing. First, we're going to find the probability of none, of no reds. So if we look at the chart, I believe we have 3 reds on there. So the probability of not getting a red is 5 out of 8 because there are 5 on there that are not red. So we're going to multiply 5 out of 8 4 times because we're spinning it 4 times. And we're going to get 0.153. So remember, the probability of at least 1, we're going to take 1 and subtract 0.153 to find that probability. When we do that, we get 0.847. Lastly, we're going to find the probability of getting not all blues. So again, we're going to do something similar. We're going to find the probability of all blue. All right, so before we were getting at least 1, now we're doing not all. So it's kind of the opposite. Since we already found out what the probability of all blues was, we can use that up from question 3. So the probability of not all blues is going to be 1 minus the probability of all blues, which is 1 minus 0.004, and that gets us our final answer of 0.996.